Hello everyone, welcome to the walkthrough introduction video for homework 4. So I'm just going to be sort of talking, mainly just repeating what's in the spec, but hopefully hearing it coming from my soothing voice will make it diffuse osmosis itself into your brain really well, and it'll set you up for success on homework 4. So just an overview. In homework 4, there's 2 tasks. The first one we're going to be talking about scanners. And so this is another class that we will introduce to you. And it's a small programming exercise. You're going to be completing the readInts class. And there are 2 fix-me's. The first is just a single line. And the second is completing one method. And so hopefully this task isn't too crazy or big and doesn't take too long. And you have to do both tasks to receive full credit for this part. Then the second task, patterns, is an exercise in writing patterns. That might sound big, but we'll explain what that is in a moment. And this is less of a coding assignment. Technically, you are writing code in a Java file, but it's more about just learning how to work with this new tool called patterns. And so there are 5 given patterns you can try to match, and you only need to complete 3 out of 5 of them to get full credit. That's an overview, and now we'll actually sort of dig into what I'm actually talking about. So last week we learned about readers, if you remember the translate reader or TR reader, and scanners are pretty similar, except they don't just read in a stream of characters. They also parse those characters into chunks or tokens. And so just to recap, last week, the readers we learned about would just take in any stream of characters and just go one letter at a time and give you the letters and not really do anything with them. The scanner, in a way, is a little smarter because it's taking those characters and processing them. And so a scanner can process its input source by assuming each token is separated by a delimiter. And so the delimiter is what breaks your input into those tokens or chunks. And a common or default delimiter is white space. So let's say we had the following stream of input and we're using white space as our delimiter. The tokens processed would be hello, I am a half human, half horse, because all of those are separated by some form of white space. It doesn't matter whether it's a space or a tab or a new line. Those are all types of white space. The delimiters are actually arbitrary. If, let's say, we decided we wanted the semicolon and the comma to be our delimiters, we could do so. And so the input, hello, I am just a horse, would result in the tokens, hello, I am just a horse. And so just to recap, a scanner is taking any source of input and it's going to parse it into tokens, chopping it up based off those delimiter. And so when it sees the delimiter, it says, oh, there's one token. And the delimiter is not included in the token's output, as you can see here, right? The output doesn't have a semicolon or comma. The input source for a scanner could be a variety of things. It could be the contents of a file. It could be something a user is typing at the keyboard, or it could be a string. And so for the example today, you're going to be working with scanners where we put in a string as an input. Scanners have a few important methods. There are more described in the spec, but these are 4 that are super relevant for this assignment. And so a scanner takes in this input, right? And it reads all of the things. And then you can actually say, iterate through and go through the tokens one at a time. And so s.hasNext, assuming s is some scanner, is true if and only if there's another token before the end of the input. In other words, there's something next to return that's not a delimiter. S.next actually returns the next token and then advances s, or in other words, moves our little iteration marker down the line. S.hasNextInt is true if and only if s has next, so there's some token in general, and if the next token happens to be some sort of numeral. And so just to be clear, if let's say we had the input 1, 2, horse, 3, 4, and we said has next in the first, for 1 and 2, it would be true. Once we get to horse, even though 3 and 4 come after the horse, it's going to return false because the immediate next token is not an int. So has next int is not saying, oh, there's some int way down the line. It's saying the very next token is an int. the next thing you'll return is an int. And so s.nextInt method, it does an s.next and then parses that token into an integer. And so just to be clear, remember with the scanner in general, we're working with some sort of input of like characters. And so usually they're going to be a string, but if we know that we want to work with integers, it comes with this awesome method s.nextInt that's going to take the next token and then make it into an int and return that int. But note that if the next token wasn't actually an int, you're going to get an exception here. And so if, let's say we had that example, 1, 2, horse, 3, 4, and we do nextInt, 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 the third time when we try to do horse as an integer, it's going to get an exception here. And so your actual task is to complete the fixmes in the class readInts. The readInts class uses scanners to take some string and read the ints out. And the ints here are assumed to be separated by white space, right? And so the readInts class has 3 different methods. One that prints the int out, or ints, sorry, plural. One that puts the ints into an array list and errors if there's a non-int, and one that puts the ints into an array list, simply ignoring all the non-integers. And so the first one has already been completed for you, and you can reference that. Your task here is to complete the second and third methods. And so if we go really quickly and look at the skeleton you are given, we'll see that first we have this printInts method, right, which takes in some string input. It makes a new scanner that's going to read that string. And then it says, hey, well, we have a next, let's print the next integer. Note that it's going to throw an exception if there's a non-integer character, right? Then we have readInts, which takes in a string, and it's going to try to put the resulting integers into this array list. But right now it's not doing that yet. And so your job is to fix this. All you have to do is fix this line. Then finally, we have smart readInts. And so I want you to notice that in both of these 2 methods, if we had a non-integer token, it would freak out and go, this can't be parsed as an integer, like exception, exception. Smart readInts is going to say, okay, this is not an integer, so I'm just going to ignore it. Ignore all my problems, everything's cool, everything's fine. And it just skips past it. And so rather than throwing an exception, you're going to have to figure out a way we can use the scanner methods we know to work around this and not throw an exception when there's a non-integer token. And that is your task for part 1. And so you've finished maybe the first task of the homework, and we're going to talk about the second half, which is regular expressions or patterns. So you just learned what scanners are and how they worked, but you might be wondering, how the heck did the scanner know when the next token string was something that could be processed as an integer, right? Because again, the scanner was working with strings, it was reading strings, but somehow it determined when the string was actually something that could be a number. To us, it might seem pretty obvious as humans, right? If we look at the string 1, 2, 3, ABC, 3, 4, 3, we know that's not a valid number because there's these letters in the middle. And on the other hand, if we look at the strings 3, 4, 5 or -10, we'd know that they're both valid, and these strings could actually be numbers. But there's all sorts of variation in what a valid number could look like, right? It could have a negative in the front, it could have like a decimal point, it could be any length, it could whatever. And so it's like, how do we know when these things look like or match the pattern for what a real number should look like? And so Java provides a way for us to do this in code through pattern matching. And there's this rich syntax, which is a really nice way of saying it, for specifying a pattern in Java. And so note that when we're talking about Java patterns, we'll sometimes say regular expressions or regex. And so like I said, there's this whole big like syntax for Java patterns. It's everything you need to know for this class at least is in the spec. And so it's rather verbose, and we don't expect you to memorize all this, but I'm going to recommend that you look at it really quick just so you can get a vague idea of how these things work, right? And so once you have some sort of vague idea, you can use this class matching.java to sort of play around and experiment with how the patterns work. So I'll just do a little demo of what this looks like. let's say we are in the homework for directory, we've compiled using make, and then we do Java matching. And so this program is going to let us do a string and then a pattern, and it's going to tell us whether that pattern matches the string we gave it. Let's say my string was just the letter A. If the pattern is A, as described here in the spec, the most characters simply match themselves. So if the pattern is just A, that should match. And it says, yep, it matches. Now, what if my string is hello? What pattern could possibly match this? It could be hello, but if I wanted to keep it more generic, I could maybe also do a pattern that says, oh, any character A through Z, any number of times, or like one or more times, right? Because again, as described here, we see plus means one or more. Somewhere in here it says that. Oh, I found it. P plus means one or more P's, where P is some pattern. And so this should work. Note that if I did hello and I just did A through Z, without the plus, it's going to look for a single character, A through Z. And so there's no match. And we were wondering, like the original reason we were curious about this was because how did the scanner know when something could be parsed as an integer? Well, let's say I had this input. I'd know that anything that was a number is going to be D and then something like that, right? But what if I had the number -10 and I tried to use the same pattern that just worked right here, right? Well, now it's a no match. And so we could say, oh, there's an optional negative in front and then some amount of digits. Oh wait, I typed that as the string. Whoops. Let's see, -34, and we're going to say optional negative or hyphen plus some number of digits. Cool. And we're going to see that same patterns works even without the hyphen because we said that the hyphen was optional. So I really recommend playing around with this and it should help you out. Yeah. And so that is the basics of matching. And again, I really recommend pausing the video and reading through the whole documentation of patterns. In fact, read the whole spec for the assignment right now, because why not? Regex are really fun and often used in the real world, but the syntax is just quite dense. There's a lot to learn, and we don't expect you to memorize every single piece of it. Even I don't have most of it memorized, but we do want you to be able to use it when you have the documentation sitting next to you. So the programming task is basically to write 5 patterns that might match certain types of inputs as described in the spec. You only need to do 3 out of 5 of them to receive full credit, and we're actually going to go over the first one together as a sort of starting point for you to do the rest of the assignment. And so the first pattern that they give you in the spec to try and match is just a valid date. Month, date, year, because we're in America and we put the month first. And so for single digit months, we can, or the leading 0 is optional. And similarly for single digit days, right? We can have 10:05 or 10:05. And we're going to assume, for example, like because we do month, day, this is a valid date, but this is not. So month is anything that can go from 1 to 12, date can go from 1 to 31, and year, we'll just say it's anything 1900 onward, because in 61B, I guess we don't believe that the year 1700 happened. And so note, technically, like February 31st is a valid date format for our purposes. I mean, we're just trying to do a pretty simple task, so it doesn't matter whether it's all accurate. And so I'm going to go over sort of how I would approach solving this problem. When you're working with regex, it's actually really helpful to use real world tools. And so there is this website, regex 101, that is really helpful for sort of building regex as you go along and seeing if they match. And so you type your regex here, and then there are some test strings, and it's going to tell you whether or not they match. So I've put in some examples test strings. The first 4 are valid dates, and the second 4 are invalid. You can pause the video and see for yourself why. And we're going to sort of go and build this string from the ground up One thing that's really helpful when using this tool is if we know we want to build the string from left to right, going from month, day, year, we can anchor our regex. And so what the anchor does is it just tries to match the leftmost character only. So for example, if I just did D, right now that's matching every single digit, but if I anchor it, now we're only matching the leftmost. And so this is going to help us as we together build this regex from left to right. So first we're going to be looking for the month. And we can sort of think about how there's two different main types of months, right? We have the single digit ones, January through September, or 1 through 9. And then we have our double digit months, October, November, December. So we can sort of start with the single digit ones maybe. And we're going to sort of put this in a group for organization's sake. And we're going to say, okay, the month could have a 0 in front. And that could be any number 1 through 9, right? Not 0 because there's no 0th month. And so we're going to say, okay, we know we can have 1 through 9 at least once, and we want to have a 0, but the 0 is optional. And so we can sort of go through here in the quick reference corner, we can see, oh, there's all these tools that might be helpful, or we could go look at our spec, right, which tells us, oh, look at P question mark denotes an optional P, 0 or 1P, or P is some pattern. And so, oops, don't mind all my open tabs. And so we're going to go, okay, why don't we put a 0 and then a question mark because it's optional. And so we see now we're correctly matching the single digit months, whether or not they have the leading 0, and we're not matching our double digits yet. And so it could be either single digit or double digit. And so we use the or expression right here. And then we have to say, okay, if it's a double digit, it definitely starts with 1. And the second thing must be 0, 1, or 2. We can't have a 3 there, right? Because there's no 13th month. And so now we see we're matching, and this is actually kind of tricky here, but because we're matching this, it's not going to like fully recognize this until we put the next character or this forward slash. This is due to the greedy nature of regex, right? And so now that we have this, we see, oh, look at all of these are successfully being matched, whereas 13 is not. And these have valid months, but we'll see that the day here and the year here isn't valid. And so eventually those will also not be highlighted. So we've done the month correctly, and now we want to go on to matching the day. And here it's again a pretty similar case. We could start with just looking at the single digit inputs, right? And so if it's a single digit, again, it must be something 1 through 9. And it could have an optional leading 0, right? Let's see. It stopped highlighting this. So let's keep building and see if that comes back, or maybe I have a bug somewhere, right? And so, okay, it could be, and again, the regex, it's pretty complicated to work with because they are like dynamic and they're shifting and they're like trying to like optimize to match as much as possible. And so we will go through and sort of fix up the day and then see if that brings back these months that just stopped matching right now. And so let's see, we could have that, or we could have a double digit month. And so for the months in the 10 and 20s range, that second digit can be anywhere 0 through 9, right? But for the months in the 30s, it can only be 30 or 31 because of the description we put in the spec. And so we're going to say, okay, if we have a 1 or 2, either 1 or 2, one of those, right? Then we could have any digit. And so we'll put D. And so this is great. We're bringing back these, right? And so if it's 1 or 2, we can have any digit. Or finally, if it starts with a 3, then the only valid choices are 0 and 1. Cool. We see all of these are matching, and the last one here is matching, but it's because we haven't gotten to the year yet. So finally, we've done month and day. We're going to do year. We know that according to the spec, it's a valid year is either going to start with 19 or 20, because we're only looking at years 1900 and up. And so we could either have 19 or 20. And after that, we could have any set of 2 digits, right? And so we're going to try to do this right now, right? D for digit, and then the brackets specify exactly twice. But notice that this actually doesn't match 1999. This is sort of due to like a PEMDAS type of thing, right? It's almost viewing this as 19 or 20 with 2 digits after, right? And it's grouping this all together. And so in order to fix that, we should put this in one group. And now finally, we have successfully matched our good dates and not matched our bad dates. And this is sort of a preview. You can reference this solution when doing your problem one, right? That's totally fine. And hopefully this is a just helpful tool for you to see how you could approach the other regex that you need to do. So I hope that you have a great day. Yeah, have fun. Homework 4 is awesome. You got it.